Good evening, everyone. Welcome to the second live session of the course Basic and Chemical
Hi,
Engineering
good evening.
and Pollution Abatement.
Good evening, ma'am.
So, do you have any doubts from the previous week's lecture?
I'm doubt in the numerical section.
Yeah, tell me.
Can you please explain it numerical again? Steady.
Ma'am, this is my first class actually. I have not attended previous classes, so
Okay.
uh,
You can watch the video lectures on YouTube. It's been uploaded.
okay.
So, which question did you have a doubt on?
Last question. We have done that numerical about concentration. I have doubt in this formula.
1 second. The last one, right? Where we found
Yes,
the
ma'am.
bioconcentration factor.
Yes, ma'am.
Yeah, so 1 second.
I want you to solve this entirely.
Okay, so last week's last question was chlorine is found in a lake at a concentration of 560 microgram per liter. So this is the concentration of the chemical, okay? And we need to find the concentration which is present in the fishes. So like I told you last week, when fishes or any organism will consume water or air, inhales the air which is contaminated, so the pollutant will tend to go and it will accumulate in its body. Is that clear?
Yes, ma'am.
Yeah, so that is called bioconcentration. And we have been asked to find the concentration of this chemical chlordane inside the fish's stomach. So we've been given this KOW, which is nothing but the partition factor. So partition coefficient of the chemical chlordane between octanol and water. So octanol is just like oil. It is an organic compound which is used as a substitute for fat. So some chemicals will be more soluble in octanol than in water, and we call those chemicals as hydrophobic, which does not dissolve in water as much as it will dissolve in oil or fat. So these compounds are called hydrophobic, and some compounds will dissolve in water more than in octanol. So we call these chemicals as hydrophilic, means which will dissolve easily in water. Okay. So in order to find out if a particular chemical is hydrophobic or hydrophilic, we divide the concentration of the chemical in octanol to the concentration in water. So, for example, you take, let's say, 100 grams of chemical and you dissolve that 100 grams in maybe 1 liter of octanol and 1 liter of water. Then this is a measure of the concentration of the chemical in octanol and to that in water. So basically, you are trying to dissolve a chemical in octanol and water, and then you are dividing the concentration dissolved in octanol. I mean, the how much of the chemical is already dissolved in octanol, and you have to divide that by the concentration in water, which means how much of the chemical has dissolved in water. So this is just a ratio. So we call this as a partition coefficient because it is technically the chemical partitioning between octanol and water. So we call this as the KOW value, or the octanol water partition coefficient.
Is this concept
Is
clear?
this concept clear?
Yes, ma'am. My doubt was regarding the numerical, like how we put the values and
Okay.
So let me come
So
to
let me
that.
come to that.
So
So first,
we have
we have
we have been given the
um,
we
we've been given the KOW value.
So
So we have this formula where log of bioconcentration factor equals to 0.79 into log of the water octanol partition coefficient minus 0.4. Is this clear? This step.
okay.
Is this step clear? We are just writing the
Yes,
formula.
yes.
And then we have to substitute all the values. So 0.79 into, we find the log of KOW, log of.
Ma'am, but the answer is getting different, like
What are you getting?
28,000 something.
Maybe you can check it once more.
Can you please tell me how you got this 3.944? Can you please solve this?
Yeah, one second. So we are taking log of BCF equals 0.79 into log KOW minus 0.4. Right. So coming to the right hand side, 0.79 into log of, what is KOW? 316,222,7.76. Minus 0.4. So what is log of 316,227.76? This number is 5.499. Are you getting this? Are you getting this?
Ma'am, just a minute.
Yeah.
Okay, okay, yes, yes, ma'am, 5.49.
Okay, and then you just have to substitute everything, and then you will get the BCF value. Is it clear now?
Okay, okay, ma'am. Yes, ma'am, I got this. 3.944.
Yeah. Okay, so we'll just go back to, yeah. So I hope you all have watched this week's lectures. So let's get started. Any more questions or doubts?
No, ma'am.
Okay, let's start with pollution. What is pollution?
Contamination of nature.
Contamination of nature. Contamination with what?
Pollutants.
Yeah, so what are pollutants?
Those substances which are degrading our environment or surrounding.
So, substances which are harmful in nature. So, harmful substances are called pollutants, and introducing these harmful substances into the environment is called pollution. So, why is this important? Because these substances can cause harm and can damage the environment. So, there are two main categories of pollutants. Can you name them? What are the major categories of pollutants?
Organic and inorganic.
That
Man-made and
comes,
natural.
yeah, natural and man-made. And we can also classify pollutants based on the source. So, based on the source, how can we classify pollutants?
Point source and mobile source.
Point source and
Mobile source.
okay. Can you differentiate between the two?
Some source which are like identified from a particular location are said to be a point source.
Yeah, like there is a well-defined origin, and they are also easier to treat. Can you tell me why? Can anybody tell me why it is easier to treat point source?
Because we know the exact location from where it is coming, so we can apply the preventive measures for that particular location.
Yeah, so once if we know that the pollutant is coming from this place, we can maybe prevent it at the site itself. Like if some industry is emitting harmful gases, we can have some filters, or maybe we can have some
Scrubber.
scrubbers, so that we can remove the pollutants at the source itself. So we don't have to worry about it spreading to the environment. Whereas in a non-point source, it is not possible. Why is that?
Because there can be multiple origins, so it is hard to treat them.
Okay, can someone give me examples of both? Example of a non-point source and a point source?
Example of point source can be a industrial emission from a stack,
Yeah.
and in a non-point source it can be erosion or
Erosion. Erosion is
yes,
pollution.
wearing away of surface can be considered it as a like
No, it is a natural
pollution.
phenomenon. Erosion happens naturally, so there is nothing harmful in it. It happens like if the top layer of soil gets carried from one place to another. I don't think it is pollution.
So we can consider vehicular emissions in a non-point source.
Okay, that is a mobile source, like you said. Um, so, what about agricultural lands? Like those that are spread with pesticides and insecticides, and then when they are watered, so the excess water gets carried off into the nearest rivers. So, in that case, will you be able to identify exactly from which field it is coming from?
Yes, ma'am.
You can.
No, no. I mean, the non-point sources are cannot be identified.
Yeah, so they are spread out. So if it is a cluster of industries or maybe like a huge land of farming area, then it is very difficult to pinpoint exactly where the source is. So in that case, it becomes very difficult to treat the pollutant. So example can be like agricultural lands or industrial cluster. And there is one more called a line source. So example of a line source is like vehicular emission. In olden days, we've had these trains which would emit smoke on the go. So those contributed to vehicular line source emissions. And even these days, we have buses or two wheelers or anything like it just pollutes on the go. I mean, the vehicle pollutes on the go, and it travels from one place to another place. It is not in the same place. So then it becomes a line source. So what happens to the pollutant once it's released into the environment? Can someone tell me what happens to the pollutant once it is released into the environment?
It can disperse.
Okay. Dispersion means what happens?
Scattering of particles, pollutant particles.
So the pollutant basically spreads out and it gets dispersed into the surrounding air or surrounding water. So that is one. The second one is dilution. So what happens in dilution?
If the concentration of the media which is opposing this pollutants is far high from the pollutant concentration.
What happens in dilution is when you, for example, this is a maybe a lake or a water body, and we have a pollutant at this place. So slowly, what happens? The concentration of the pollutant is at this place is higher. So slowly, it diffuses and it kind of disperses, and its concentration will become dilute as it continues mixing into the water. So initial concentration might be very high, but as time passes, it will become dilute as it mixes with the surrounding water, and its concentration will get reduced. And the third one is deposition. Can you give me examples of deposition? Where can this be found?
Bioaccumulation.
No. Anybody else?
riverbed settlement and all this will come under this category.
Sorry?
Deposition of pollutants in riverbed and all this will
Yeah.
come under.
Yeah. So especially when we have sediments. So when we pollute a river, and then what happens is the pollutant after some time it will tend to settle at the bottom of the river, so onto the sediments, and this is called deposition. And then we have degradation. What happens here? What is the meaning of degradation?
That means that pollutant will degrade, or it will what it is called, make it into small pieces, and it will.
Okay, but how it will degrade?
It's because of the chemical reaction.
Okay. So chemical is one possibility. Can you tell me another possibility?
Biological contamination.
Yeah.
Biological contamination.
Biological degradation.
Yeah, so there can also be biodegradation.
Then thermal degradation is also possible.
Thermal degradation in natural systems. Are you sure? Okay, so under
And
chemical there could
chemical
be
degradation.
Yeah. So chemical degradation, maybe there will be other chemicals present already in the source, which can react with our pollutant and it can degrade the pollutant. Or there can be photolysis or photocatalysis. Photocatalysis is not possible, but photolysis is definitely possible. So photolysis is where you have UV radiation. So from this UV radiation, we get photons. So these photons will react with water and they will produce hydroxyl radicals. This is a very slow process. So these radicals will attack the pollutants. So this can also happen. And then there is biodegradation where we have bacteria and other microbes which will feed on the pollutant, and by feeding it will degrade the pollutant completely. So this also takes time. Both of these are very slow processes. So if a pollutant enters into a river or a lake, there can be these 4 ways in which the mass of the pollutant can be distributed. So either it gets dispersed or it gets diluted, or there could be loss of pollutant happens only with the last 2, that is through deposition on the riverbed or through degradation. So in the first 2 you don't have any loss of mass, it's just that it is spreading from one place to another, but in the last two processes we have mass loss as well. Okay, so now that we've seen pollution, can you tell me what is water pollution?
Any kind of contamination of water body, that is called water pollution.
Yeah. So this pollutant can be physical, chemical, or even biological. So we will see each of these. So physical pollutants. Can you give me some examples of physical pollutants?
Plastics.
Suspended solid.
Yeah, suspended solids. There was another answer.
Plastics.
Plastics.
That
That also comes under no, that is a floating pollutant. Yeah,
So
but
that is physical pollution.
yeah, but that is also easy to remove. That is like we don't generally consider that as we do, but it's like far easier to remove than suspended solids and dissolved solids.
Grit particle.
Grit, yeah, grit is also there. Grit will come under which category? Suspended or dissolved?
I think suspended, ma'am.
Yeah. And then we have dissolved solids. So these are chemicals which can be completely dissolved and which need to be separated by evaporation. And then turbidity. So what is turbidity? What is turbidity?
Presence of calcium and manganese ions.
Calcium and manganese. Calcium
Sorry,
and
magnesium. Magnesium.
what do they do?
They will provide turbidity to water bodies as calcium carbonate equivalent.
So you're saying if water contains calcium carbonate, that means it is turbid.
Both calcium and magnesium ions.
Okay, then tell me what about hardness?
Ma'am, my answer is changed, ma'am.
Okay, so turbidity is when light gets scattered by colloidal particles. Okay, so colloidal particles are very small particles that don't dissolve and they remain suspended in the solution and they give rise to turbidity. So if you have a turbid solution, and if you pass light through a turbid solution, for example, you have a turbid solution here, then you have a source of light here. So this light will not travel in a straight line. Instead, it will get scattered. So if you hold a torch or some source of light next to a turbid water, in front of the turbid water, then you won't be able to see the light clearly because it is not traveling in a straight path. It is getting scattered. So that is turbidity. And then so if we have too much of salt, then what happens to the water? Becomes more conductive. So what is conductivity?
The tendency of electrons to pass the electricity through the ions.
That's the tendency of electrons, or no, when I say something is conductive, what do I mean?
The electricity is generally passing through it.
Yeah, so conductivity is the ability of a substance to pass electrons or help, I mean, it is conducive to the transport of electrons through it. So when we have too much of salts, then it means the conductivity of the water is going to be high. So when you take seawater, for example, it has too much of salt. So that is why it is more conductive than just tap water. So these are examples of physical pollutants. Then coming to chemical pollutants. Can you name some chemical pollutants?
Industrial discharge.
Industrial discharge containing? Can you be a little more specific?
Nice.
Sorry? I think you have lost your connection.
Am I audible now, ma'am?
Yeah.
Yeah. So I was saying the industrial discharge, any kind of industrial discharge, and the pesticide would be chemical pollution.
Okay, pesticides. So when you say industrial discharge, I want you to be a little more specific because industrial discharge can have many different kinds of chemical pollutants mixed together. All of those are pollutants, so I just wanted to have a specific answer. So there
Ma'am,
can
industrial.
there can be pesticides, there can be heavy metals.
Yes, ma'am. Just like cadmium, arsenic.
Yeah. And like there can even be organic matter that we get from sewage. All these are examples of chemical pollutants. And also one more to the list, hardness. So what is hardness?
The presence of calcium and magnesium ions as CaCO3 equivalent.
Calcium and magnesium ions.
Heavy
Can you
metals.
elaborate how they will contribute to hardness?
Heavy metals can be also cause of this.
Cause of?
Metals in water.
No, what do these metals cause? You were about to finish your sentence.
Any kind of metals.
So you're saying metals can cause hardness?
Yeah.
Not all actually. There is just salts of calcium and magnesium. So salts of these two elements are known to cause hardness. And again, we have two different types of hardness. One is temporary hardness, and the second one is permanent hardness. Can you differentiate between the two?
We can remove the temporary hardness, but we cannot remove permanent hardness.
We cannot remove. No, we can remove both. So I want you to distinguish between the methods, like how we remove temporary and how we remove permanent.
Before that, could you please give me some physical meaning of that hardness? What is really hardness as far as this environmental engineering point of view?
Hardness is nothing but
yeah, I am a mechanical engineer. As far as a mechanical engineering is concerned, hardness, one property hardness is there. In mechanical engineering,
I understand. I'm also a civil engineer, so hardness is a different thing. But when it comes to environmental engineering, it's a different concept. So hardness means that when we have some salts, like for example, salts of calcium and magnesium in water, it makes lathering difficult. Like for example, when we say we are having hard water, that means we cannot use soap and produce a lot of lather. So it prevents the formation of lather, and that's why when we wash clothes using hard water, we need to use a lot of soap for it to lather and get the dirt removed. And also when we use hard water in industries, example in boilers and so on, so presence of salts of calcium and magnesium can cause scaling. So scaling on the sides of the boilers, like with the prolonged usage, it could cause scaling. And what happens is that with time, the scales will lead to non-uniform heat distribution. I mean, they will tend to absorb most of the heat and will not let the water heat properly. So these issues are there in industries. So that is why it is advisable to not use hard water in industrial boilers. Is that clear?
Okay. That means, see, this calcium and magnesium ions will be present in the water.
Yeah.
If you want to say, that means normal water and hard water means this kind of salt will be there.
Yeah.
Okay. Okay.
Excuse me for a second. So that is why we treat hardness also as a type of pollutant. So generally, when we use groundwater, we tend to find that the water is slightly more harder than tap water. So you must have heard that the water in this particular area is hard, and in that area it is better. So it's because when we use hard water over time, it can cause scaling, and also when we tend to use it for washing, etc., we might tend to use a lot more soap than what we use with not water that is not as hard.
Agree, agree. Actually, the main responsible culprit is this calcium and magnesium.
Yeah, salts of calcium and magnesium. So hardness is of two types: temporary hardness and permanent hardness. So can someone differentiate between the two, like how we can remove temporary hardness and how we can remove permanent hardness?
Ma'am, temporary hardness can be removed by boiling that hard water.
Okay.
And talking about permanent hardness, we can remove using several methods like soda lime process.
Yeah, lime soda.
Yes, ma'am.
So can we remove? I mean, can you tell me what salts will contribute to temporary hardness and what will contribute to permanent hardness?
Generally, bicarbonates are there in temporary hardness,
Bicarbonates of.
calcium and magnesium.
Okay.
And in permanent hardness, it's carbonates only.
Carbonates only. Are you sure?
Yes, ma'am.
If carbonates are, so you're saying temporary hardness is only bicarbonates and permanent hardness is only carbonates.
Maybe sulfates can be involved.
Before that, you can also have carbonates of calcium in this temporary hardness. So, can you tell me why it is easy to remove?
maybe they are in a limited quantity. Um,
So when you boil water containing these salts, like salt carbonates and bicarbonates of calcium, then what happens is that after during boiling, the calcium carbonate will form. Even if it is bicarbonate will form calcium carbonate. It will lose the hydrogen and form calcium carbonate. So this calcium carbonate is insoluble in water, and it will precipitate. So it is easier to remove them. But when we talk about permanent hardness, it can be caused by calcium sulfate, magnesium sulfate, and magnesium carbonate also. So this is slightly difficult to remove because it does not form calcium carbonate upon boiling. So that's why we need to go for processes like lime soda process, where we add soda ash and calcium carbonate, bicarbonate, and it is added in steps. So then it will be
I mean,
easier
soda
for.
lime process, I think we add calcium hydroxide so we can make the precipitates out easily.
Yeah. So we add calcium hydroxide and then it will form calcium carbonate. So first we have to add soda, that is sodium carbonate, and then this CaOH, so that it will form calcium carbonate and then it will precipitate out. So that's the difference between the two types of hardness. And then third we have biological pollutants. So can you tell me examples of biological pollutants?
Biological pathogens, bacteria, this kind of.
Bacteria, pathogens. Viruses,
Volatile acids.
volatile acids. Can you rethink and tell me which category it will come in?
Should come in biological only, I think.
How?
Because they are organic in nature. Volatile acids are.
No, we are not talking about whether a chemical is organic or inorganic. We are just talking about physical, chemical, or biological. So what you said will come under chemical pollutant because it's an organic compound. Okay, so now we will move on to air pollution.
Virus.
Yeah, that will also come under biological. So similar to water pollution, air pollution also means the presence of abnormal levels of contaminants in air, which can be harmful. And there are various types of air pollutants. Can you tell me some types of air pollutants?
VOCs.
Sorry?
VOCs, volatile organic matter. I mean, volatile organic compound.
Yeah, VOCs, but do they come under gases or particulates?
Ma'am, particulates.
You just said volatile organic compounds. So if something becomes volatile, will it remain as a particle?
Okay, in the particulates, we can consider PM 2.5, PM 10.
Yeah, so we have mainly PM10, which is particulate matter 10, and PM2.5, which stands for particulate matter 2.5. So the 10 and 2.5 here are nothing but the diameter or the size of the particle. So particles whose diameter is less than 10 is considered as particulate matter 10, and those whose diameter is less than 2.5 microns, both are in microns, so micrometers. So less than 10 micrometers, these will come under PM10. Less than 2.5 micrometers diameter, then it will come under PM2.5 category. Both of these are harmful, and especially PM2.5, because PM10 will go and it will settle in our nasal tract, but PM2.5 can travel further into our nasal pathway, and it can get deposited on the lungs also. And from the lungs, it can dissolve into the bloodstream and it can spread to our entire body. So, especially if these particulate matter, these are just solids, but if these solids also contain other pollutants, like for example, PM10 is loaded with some heavy metals, or 2.5 is also loaded with some heavy metals, then it becomes even more dangerous. Sometimes these particulate matters can also contain microbial spores. Like for example, you have some mold which is growing on trees or plants. Then maybe during the mornings, there are some organisms which will release spores. So these spores can travel for a long distance. It can settle on dust particles, and it can travel along with the dust particles. So that way, these particles become carriers for these microbial spores. And then we have soil pollution. So soil pollution, can you tell me what is the major cause of this? How soil is polluted?
Using of pesticides.
Pesticides, okay. Agricultural runoff.
Fecal sludge contamination.
Sorry?
Fecal sludge contamination.
Fecal sludge contamination. So that happens only if you directly apply the fecal sludge onto the land, right?
Actually, in rural area, they used to dispose their fecal
Yeah.
sludge outside in their land.
Yeah, that is definitely soil pollution. So that comes under the category of like waste disposal. So when we talk about waste, there can also be solid waste, right?
Plastics.
Yes. Any solid waste that we throw will end up in some kind of a landfill. So landfill or maybe a dumping site. So then that pollutes the soil underneath. And one other source is wastewater. So when we dispose wastewater directly on land instead of treating it and then reusing it, what happens is that the pollutants in the wastewater, they will tend to, for example, if this is the soil surface and we are pouring some wastewater into this, so what happens, the pollutants over time, they percolate through the soil. That means they travel. So they travel and they tend to spread. So what happens, this entire area becomes polluted. And for example, if there is some groundwater source nearby, then this will also pollute the groundwater there. So major wastewater sources include industrial effluents, sewage, etc. And then when we say solid waste pollution. I just told you about how solid waste gets dumped on land, right? For example, you imagine this is the heap of solid waste that is dumped on land. So what happens is some of the waste will start to decompose over time. Okay, and when something organic decomposes, it tends to release a lot of liquids also. So you must have observed if you leave garbage for a long time in a closed container, it will start decomposing and there will be some liquid that is coming out. So
That is
that
called maybe leaches of
yes,
landfill.
yes. So that liquid, especially when that liquid mixes with rainwater, if there is rainfall and this liquid will mix with the rainwater, then there is a high possibility that it percolates down because rainwater volume will be more, so it will the leachate will dissolve into this and it will percolate through the entire it will travel downwards into the soil and it will tend to pollute the groundwater there. So leachate is nothing but highly concentrated liquid which is generated at waste disposal sites. Okay, and then so what are the impacts of water pollution? Like, why are we so concerned about water pollution?
That would be impact on agriculture, health, ecosystem, plants.
Could no, like, can you tell me more direct ways in which water pollution can impact us?
Threat to human health.
Yeah, before we talk about human health, what about other organisms?
Aquatic species can be harmed.
Yeah.
Yeah. So when we talk about impacts of water pollution, we can have the first and foremost impact is depletion of oxygen. So, and this oxygen depletion follows a curve known as the oxygen sac curve. So before we talk about oxygen sac curve, can you tell me what is the maximum concentration of dissolved oxygen in water?
Ten milligram per liter.
You're close. So it's around 8 to 9 milligrams per liter. So this is the maximum solubility of oxygen in water. And we also call this as saturation concentration. So in naturally occurring waters, especially close to the source, like for example, you go to places like Gangotri and all, there you will find the water to be having high levels of oxygen, close to 8 to 9 milligrams per liter. But as the river goes, it reaches other places, so it gets polluted, and during that time, the oxygen concentration comes down. So why does that happen? We'll look into it now. So we can divide, for example, we are talking about a river here. So we can divide the river into sections. So this is the place where there is no pollution. The river is flowing. It has just originated, and this we call it as clean zone. So here the fishes and planktons live and they thrive. So let's say at this place we are adding some pollutant. So what happens? The oxygen which was straight, I mean it was like saturated and it is a straight line, the oxygen level gets depleted slowly. Until it reaches this value. Okay. So here we are adding the pollutant. Now can you tell me why when we add pollutant the oxygen level goes down?
The oxygen demand of any microorganism increases as the organic pollutants can degrade the.
Yeah, so what happens when we add any chemical pollutant or organic pollutant is the bacteria will decompose it. Okay. So when the bacteria decomposes the organic pollutant, it needs oxygen for survival. So for the metabolism and for breaking down the organic matter, it needs oxygen. So what it will do, it will take all the dissolved oxygen present in the river and it will break down the organic pollutant. So that is why the dissolved oxygen level will come down. So initially it was around 8 to 9 milligrams per liter. But slowly, as the bacteria tends to degrade the pollutant which was added, then the oxygen levels will drop down because the bacteria needs oxygen to break down the organic matter. So, organic matter is like food for the bacteria. But in order to break it down and in order to multiply, it needs oxygen. So, if there is food, then definitely it will use up the oxygen and convert the organic pollutant into energy. So this zone is called the decomposition zone. So in this zone, there are not many fishes because the oxygen level is low, and the water becomes discolored, like it's not clear. It becomes very muddy, and most of the fishes are dead. So, and then we go to the next zone, which is the septic zone. So in the septic zone, the oxygen level does not improve much. So it is still low. But why do we call this the septic zone? Because there are two types of decomposition: aerobic decomposition and anaerobic decomposition. So when there is enough oxygen for the bacteria, they will use up that oxygen for survival. So this is called aerobic digestion or aerobic decomposition. And the second one is
Can you please
anaerobic.
repeat this? Sorry, I missed.
Yeah, so I was saying that when there is enough oxygen for the bacteria, then that oxygen will be used by the bacteria for their growth and breaking down the organic pollutants. So that is aerobic decomposition. And then the second category is anaerobic decomposition. So here we don't have oxygen, so the bacteria will not use oxygen. In fact, the bacteria which was using oxygen will die, and then there will be another kind of bacteria which will grow in this condition where there is no oxygen. So in this case, oxygen will not be used for survival. Instead, the bacteria will rely on other sources like maybe nitrates or nitrites for their growth. So since this does not happen in the presence of oxygen, this is called anaerobic. And anaerobic bacteria are also a different type of bacteria which will grow in this condition. So it is not aerobic bacteria. Aerobic bacteria will thrive only in the presence of oxygen. If oxygen is not there, then the aerobic bacteria will die. Instead, anaerobic bacteria will grow, which will live on nitrates and nitrites as its electron donor. So then, electron acceptor. So this zone where there is no oxygen becomes anaerobic. So here anaerobic conditions will develop. So generally, when we talk about anaerobic decomposition, here the organic compounds are broken down into methane, hydrogen sulfide, and carbon dioxide. So here the organic compounds which contain carbon will be converted only into CO2 and water. Here also CO2 and water will be produced, but along with that we also get methane and foul smelling gases like hydrogen sulfide. So because of these gases, this zone also becomes smelly. So you must have seen in places where sewage is dumped, fresh sewage will not have as much foul smell. But if you let the sewage stay there for maybe 1 or 2 days, it will start smelling bad. Why does that happen? It's because it is getting decomposed anaerobically using anaerobic bacteria, and that is releasing these gases into the air. So even the same thing can be observed in the river also. So when we have a pollutant at this point, so first there will be some decomposition, and then as the oxygen level drops, anaerobic conditions sets in. So under anaerobic conditions, the smelly gases will be generated. So that's why in some stretches of river you will get the foul smell. So when anaerobic conditions develop, there are certain fishes that can survive in these conditions also. And then we have the recovery zone. So here in the recovery zone, in this stage, what happens is most of the organic pollutant has been degraded first by aerobic bacteria and then by anaerobic bacteria. So most of it is degraded. So slowly, what happens? The oxygen level comes to its previous value. So the oxygen level climbs up and it slowly comes to its previous levels. That is the level before the pollutant was added. So this, and then we have the clean zone. So clean zone is just like how it was before the pollutant was added. So oxygen level comes back to normal. and the pre-pollution conditions are restored. So is this clear? This is called the oxygen sag curve because there is a sag here. So this is like a curve. Any questions?
I mean, which sources are these anaerobic bacteria are dependent on if they are not on oxygen?
Yeah, just like I told, nitrates, nitrites.
Means they are not natural. I mean, they are like man-made
No,
organisms.
no,
It
no.
means.
It's not about natural or man-made. It's about what is their source of electrons. I mean, when you have aerobic bacteria, they rely on oxygen for the metabolism to take place. Now, anaerobic bacteria will do this metabolism using nitrates or nitrites. So they are just replacing one molecule with another molecule. That's it. Is that clear?
Yes.
Okay. So yeah, so first of all, the first impact was oxygen depletion. So next, coming to humans. So human health also gets affected by pollution. So, for example, you have heavy metals. So contamination from heavy metals like arsenic can cause skin damage, nerve damage, or if the fluoride concentration in water,
Cancer.
cancer. Yeah, sometimes if there are carcinogenic pollutants in the water, then it can cause cancer also. So if the
Mercury,
fluoride concentration is high, sorry,
mercury in water.
yeah. So fluorosis is caused by high concentration of fluoride in water, and if there is nitrate, then it could cause blue baby syndrome. And there is also contamination from pathogenic bacteria and virus. Okay, so then let's come to impact of air pollution. Can you tell me what impacts of air pollution are there?
Majorly asthma.
Sorry.
It's asthma majorly. Respiratory issue.
Yeah, respiratory diseases. Only respiratory diseases?
Visibility problems.
Yeah.
Migraine.
Yeah, that could also be. So there can also be damage to buildings.
Damage to buildings as well.
Sorry?
And damage to buildings.
Yeah. So, just like we discussed, we have different types of air pollutants. The first one is gaseous pollutants. So, can you give me examples of gaseous pollutants?
Some SOx, NOx,
Yeah.
carbon monoxide, carbon dioxide, methane, nitrous oxide.
Nitrogens.
Yeah, so SOx, NOx, and carbon monoxide, carbon dioxide, methane. So, all this will come under gaseous pollutants. So, of these, carbon monoxide is highly dangerous because it can bind to hemoglobin and it will reduce the oxygen supply. And NO2 will react with the hydrocarbons to produce smog. And when SO2 combines with particulates, it can cause breathing issues.
And we can also add VOCs.
Yeah, we can have VOCs also. So next, coming to the impact of soil pollution. What will happen if the soil is polluted?
So basically, it's damaged agriculture.
How?
Because pH level maybe destroy and natural nutrients will be destroyed after this.
Okay. But there can also be reverse. Let's say maybe you have soil and it is heavily contaminated with some metals like heavy metals like arsenic or mercury, chromium, and so on. Because of some industrial effluent has been dumped in this place. So the soil is completely contaminated, and then we have plants growing here. So what will happen? So from the roots, these heavy metals, they can travel and reach the shoot also. So when we do agriculture in this kind of land, so the crops may have these heavy metals. So these crops are consumed by us. So indirectly, we will also get exposed to these heavy metals through the soil. Okay. Coming to impact of noise pollution. What are the impacts of noise pollution?
Hearing loss.
Sorry?
Hearing loss, man.
Yeah, hearing loss. That is a type of physiological impact. And there can also be psychological. So psychological impact can be just irritation, annoyance, or maybe sleeplessness, which is all due to noise. Okay, coming back to air pollution. So when we study air pollution, we generally assume that the pollutant will travel as a plume. So plume is nothing but a parcel of polluted air which is moving through the atmosphere. So when we talk about moving, there are three ways in which the pollutant will move through the air. So the first one is by diffusion. So diffusion is due to the concentration gradient. For example, you have plume which contains some pollutant and it is having a high concentration when compared to the surrounding air. So what happens? There is diffusion happening, so because of which there will be movement of the plume. The pollutant will tend to move from a place of high concentration to a place of low concentration. So it will tend to spread out. And then there is advection. Can you tell me what is advection? What is advection? So advection is nothing but bulk motion. So if you have a plume of air and then there is heavy wind that is coming, so what happens? This plume is moved from its place entirely. So this is also movement, but it is caused by some other media. For example, if it is happening in water, then it is advection in water. If it is happening in air, it's advection in air. So it is caused by movement of air or wind, and it moves the entire plume to a different location. So with higher velocity, it will travel to a longer distance. And the third type is convection. So convection is a combination of diffusion and advection. So in advection, we saw how strong winds or maybe strong water currents will tend to move the pollutant from one place to another place. Now, during this movement also, since there is a concentration gradient within the plume, from the plume to the outside, there will be movement of pollutant from inside the plume to outside. So this is convection. This is diffusion happening alongside advection. So there is movement along the direction of the wind or along the direction of the water, and there is also lateral movement because of concentration gradient. So there is also some kind of mixing happening here, as well as some movement happening in this direction or the direction of the wind. So in this way, if convection happens, then there is more rapid and faster movement of the pollutant, and it won't stay in one place. So that is why convection is better, because if you have a polluting industry or something, and there is convection happening, then that means that the pollutant won't be the high concentration of the pollutant won't be staying in one place or one particular location. It will diffuse quickly, and then it will also move to a different location, so that aids in better dispersion of the pollutant and it reduces the concentration. So there are some factors which will decide how the pollutant is going to travel, and one of them is called the lapse rate. So lapse rate is the rate at which the atmospheric temperature will decrease with respect to height. So on the x-axis we have height, and on the y-axis we have temperature. So when you travel to hill stations, have you observed that the temperature there is slightly lesser than in flat areas?
Can you repeat the question, please?
So I was asking, when you go to hill stations, the temperature there is lesser than the temperature in flat areas. Have you observed this?
Yes, ma'am.
So can you tell me why this could be?
Because of pressure difference.
Because of
Pressure difference.
no. What happens is the temperature will reduce as we keep on increasing the height. So near the surface of the land, the temperature is slightly higher, especially during daytime, because the soil is made up of minerals, and minerals are nothing but metals, and metals are highly conductive to heat. So they readily absorb sun's radiation, and they increase the temperature of the air immediately above the soil layer. So the temperature near land will be slightly higher, but as we move up and up, the temperature will come down. So as we move up and up, the temperature will come down, and this is called the lapse rate. The rate at which temperature gets reduced or decreased with respect to height. Is that clear? So there are two types of lapse rate. One of them is the adiabatic lapse rate. And the environmental lapse rate.
I have question. I have one question that the concentration of pollutants are there in somewhat altitude. So why there is no raise in temperature?
I'm not getting your question.
There are like certain pollutants present in some height, some certain height.
Okay.
Then there should be an increase in temperature. No?
Why?
because of thermal collision between the pollutants.
No. See, inside, so I was just telling you, right? So if there is an industry, it will generate pollutants in the form of plumes. Okay. So these plumes, inside these plumes, the temperature will be high. Okay. But compared to the surrounding atmosphere, the high compared to only the surrounding atmosphere. So outside the plume, the temperature is going to be low. Inside, it will be high. So when we talk about
So are you
labs,
saying that dilution happens here?
no. I'm coming to that. Wait. So when we talk about lapse rate, we were talking about the environment in general, not uh, about specific pollutants or anything. I was just telling you in a place. Just imagine, like if you go to a hill station or somewhere, with increasing height, you will observe that the temperature will go down. So this is observed in the case of. This is observed in the environment generally. So, and when you said the high temperature could cause mixing, yeah, that will also happen. So I'll come to that later. For now, you just understand that in general, when we increase the height, when we go up and up, the temperature will go down. So that's why when it starts raining also, initially to a certain height, it will the raindrops will fall as ice cubes, and then as it comes closer to the surface of the earth, it will condense. Sorry, it will melt and it will form liquid. So that's what. So when you go to a very large height, the temperature of the atmosphere or the surrounding air is much lesser than what it is near the earth. And the rate at which it reduces is called the lapse rate. So we have two different kinds of lapse rate. One of them is the adiabatic lapse rate. So adiabatic means something which does not exchange heat with the surrounding environment. So in this case, we are talking about a parcel of air. So imagine just a parcel of air, not a pollutant. So here we have a parcel of air, and it is moving upwards. Okay. And it does not exchange any heat with the environment. And this parcel of air, even though it does not exchange any heat with the environment, it will continue to expand slowly. Okay, so because of pressure difference, so it will continue to go bigger and bigger as it moves up. And as it expands, it tends to cool down. Okay. So the rate at which this cooling down happens is about 9.8 degrees per kilometer for dry air. Is this clear?
Yes, ma'am.
And then we have the environmental lapse rate. So environmental lapse rate is adiabatic lapse rate is for a specific parcel of air. Environmental lapse rate is generally for a given place how the temperature will reduce with respect to height. So it depends on the place and time. So it varies. If it is winter, maybe the lapse rate will be slightly higher, and if it is nighttime, it will be different from what it is during daytime. So environmental lapse rate depends on the location as well as the what time it is. Whereas adiabatic lapse rate is fixed. So for any parcel of air, as it moves up, it's the rate at which it loses the heat is going to be 9.8 degrees Celsius per kilometer. So based on these two lapse rates, we can define the atmospheric stability. So here we have three conditions: unstable, neutral, and stable.
So before we go into these, I want you to understand that
I want you to understand that the moment of the air parcel
depends on
the direction
and speed of
and
the wind.
speed of the wind. So if we have a wind
that is
that is having a high speed and it tends to like
move the air parcel
upwards,
upwards,
so then that is affected, right? So if there is a high speed wind blowing here, then it tends to move the air parcel upwards. So that's what.
movement of the air
Movement of the air parcel depends on the direction and the speed of the wind. So if you have winds in two different directions, one is upwards and another one is downwards, then if one in one direction it goes up and the other direction it comes down, so basically it's not going anywhere, it's staying in the same place. Okay, talking about the unstable condition first. So we are going to draw the stability diagram here. So this is height and this is temperature. So first, let's draw the environmental lapse rate. So with increasing height, the temperature is going to get low. So imagine at 0 meters from the earth, the temperature is around 40 degrees. Then as we go up, and maybe we are reaching 1 kilometer here. So here the temperature, say it's around 20 degrees Celsius. That's what I meant. So temperature will reduce if we go like slightly above. So this is the environmental lapse rate, or this is the lapse rate for a given place at a given time. For example, in Chennai at 12 p.m. This is the lapse rate. So this can be different from the lapse rate in Delhi, Mumbai, or any other city. So the environmental lapse rate depends on the surroundings and the environment, like which location it is, what time of the day it is, and so on. And then
Ma'am,
we
what
have
is the unstable condition here?
yeah, I'm coming to that. First, I want you to understand this completely, like lapse rate and all. So then we have the adiabatic lapse rate, which is going to be sorry. So the adiabatic lapse rate is like it is 9.8 degrees Celsius per kilometer. Now I'm drawing the adiabatic lapse rate in dotted lines. So this is the adiabatic lapse rate. I'm denoting it by tau, and this is the environmental lapse rate. So here at this point, these two lapse rates coincide. So adiabatic lapse rate is 9.8 degrees per kilometer. So for every kilometer that we move up, the air parcel's temperature goes down by 9.8 degrees Celsius. And at this point, these two lapse rates will coincide. So here, for example, if you have any air parcel that is moving up and it is reaching this point, what will happen? If the air parcel gets pushed up by the wind, then say for example it is reaching this point. Okay, so when it goes to this point, the surrounding air is hotter or colder?
When the temperature is reduced, the air should be colder.
Are you sure?
Ma'am, which point you are talking about?
This point. This is 2 and this is 1. So the air parcel has moved from 1 to 2. So tell me, at 2, the surrounding air is hotter or colder?
And if the temperature is reduced, the surrounding air should be colder because the height is also increased.
Are you sure?
Yes, ma'am.
Okay, so the surrounding air is colder, and this will, since the air is hot and the surrounding air is, the air parcel is hot and the surrounding air is colder, so that will force the air parcel to move upwards. Okay, so it will continue to expand and it will move upwards. And similarly, if the direction of the wind is downwards and it moves the air parcel to this point 3, it comes down. So here, what is the scenario? Is that surrounding air hotter or colder?
Since the third region is the air parcel is coming down, right? So temperature should be higher.
So you just check this environmental lapse rate. So environmental lapse rate is like this. So at this point, so for this point, the temperature of the air parcel is, it could be somewhat 30 degrees, and the environmental lapse rate at this height is slightly higher. Maybe it's around, let's say, 35 degrees. So at
So
any
when
point,
this air parcel is trying itself to get in the upward direction to be stable, I think.
no, that's not it. So the air parcel is moved down, and when it comes down, the air parcel's temperature is lesser than the surrounding air. Just compare this with the, I'll draw it here again. So this is the environmental lapse rate, and this is the adiabatic lapse rate, and we have the air parcel here. So here, just check what is the temperature. So here, one second. So here the temperature is around, at this height, the temperature is 30 degrees Celsius. So compare this with the temperature on the environmental lapse rates temperature. So for this height, should be somewhere here. So let's say this is 35 degrees. So this means that at the location of this air parcel, the surrounding air's temperature is 35 degrees, and the air parcel's temperature is itself 30 degrees. So the air parcel's temperature is slightly lesser than the surrounding air. So when the air parcel is cold and the surrounding air is hot, it cannot expand. The surrounding air will not allow expansion of the cold air parcel. So if there is no expansion, then it's not going to lose temperature. Instead, it is going to gain temperature, and it will therefore continue to move downwards. So in the unstable condition, when the wind moves the air parcel up, it continues to move up. And when the air parcel, when the wind moves it down, it continues to move down.
clear?
Is this clear?
Can you please explain again?
Yeah.
Yeah.
So
So
I
I
was
was
just
just
saying
saying
that
that
imagine there is an air
imagine there is
parcel
an air
here.
parcel
It is
here.
following
It is
adiabatic
following
lapse rate.
adiabatic lapse rate. Okay.
And this
And
is the
this is the
environmental lapse
environmental
rate line.
lapse rate line.
So
So at this
where
point
these
where
two will
these two will
coincide,
coincide, imagine we have an air parcel here.
And
And
imagine
imagine
there
there
is
is
a
a
strong
strong
wind which
wind
is
which is
moving the
moving
air
the air
parcel
parcel
upwards.
upwards.
So
So
what
what
happens? It
happens?
will
It will
move up
move up
because of
because of
mechanical
mechanical
force
force
by the
by the
wind.
wind.
So
So
once
once
it
it
reaches
reaches
this
this
position
position
2,
2,
so
so
will
will
it
it
move
move
up
up
or
or
down?
down?
That
That
is
is
the
the
question.
question.
So
So
in
in
order
order
to
to
decide
decide
if
if
it
it
is
is
going
going
to
to
move
move
up
up
or
or
down,
down,
we
we
need
need
to
to
compare
compare
the
the
temperature
temperature
inside
inside
the
the
air
air
parcel
parcel
with
with
the
the
temperature
temperature
outside
outside
the
the
air
air
parcel.
parcel. Clear?
Ma'am, suppose the temperature or the surrounding temperature is higher in the downside, I mean in the bottom region, and the air parcel should move up. And because the that's because the air parcel temperature is less than that of the surroundings temperature. It will go up.
Air parcel's temperature is less than the surrounding temperature. No. In that case, it will continue to move down because only if there is heat inside, there will be expansion, right? If the air parcel is colder than the surrounding air, then why will it expand?
It's very confusing.
Yeah, you need to go back to physics a little bit to understand these terms, adiabatic and all. So, since it is outside the scope of this course, I'm not going deep into it. So, this is the basic thing. Like, if the air parcel's temperature is less than the surrounding air, then it's not going to expand.
Can we relate to volume little bit?
Yeah, you can. So, you when the temperature, surrounding temperature is lower than the air parcel's temperature, then the volume of the air parcel
What?
will increase,
Yes, ma'am.
right?
Yes,
Yeah,
ma'am.
that's what I was trying to say. And when the surrounding temperature is less than the air parcel's temperature, there won't be any increase in volume. There will be reduction in volume, and then it will not move upwards. Only if it expands, it will cool down. If it does not expand, it's not going to cool down. So if it is not going to cool down, it is going to remain in the same state and it will continue to come down.
Or we can say that colder temperature is there, so maybe the molecules are quite denser, so the air parcel can move down.
Not understanding your question.
Since the upper part that is a colder surrounding region, the denser particles are there, so maybe the air parcel is that's why moving down. We can say.
No, it's not because of density, it's rather because of expansion and contraction. So when the air parcel's temperature is lower than the surrounding air's temperature, it will tend to compress and it won't expand. So if it doesn't expand, it's not going to move up. So it will continue to contract and continue to move down because the wind is blowing and it is moving in that direction. So it will continue to contract and it will move down only. So this is the unstable condition where like the movement of the wind only influences the movement of the air parcel. So if the wind is moving upwards, then it will continue keep on moving upwards. And if it is moving downwards, if the wind is moving the air parcel downwards, then it will keep on moving downwards. Then we will see the next condition, which is neutral. So again, this y-axis is height and the x-axis is temperature. So again, we have the environmental lapse rate, and in this condition, so the adiabatic lapse rate is parallel to the environmental lapse rate. So the adiabatic lapse rate is fixed at 9.8 degrees per Celsius, degrees Celsius per kilometer. Whereas the environmental lapse rate differs from place to place. And imagine that it is in such a place where it is parallel to the adiabatic lapse rate. So in this case, what happens? So in this case, the air parcel is like wherever it moves, it will stay there. For example, if the air parcel is here, if the air parcel is here and the wind is moving it to this position, it will stay there itself. It won't move further upwards. And similarly, if the air parcel is moving it down to this position, it will continue to stay there and it won't move downwards.
I think it is there's no temperature difference. That's
Yeah.
why.
Yeah. So since there is no temperature difference, it is only because of the movement of the wind. And the third condition is the stable condition. So this is the environmental lapse rate here. First we'll draw the adiabatic lapse rate. And then the environmental lapse rate is like this. So this is at 9.8 degrees per degrees Celsius per kilometer. But this environmental lapse rate is slightly like this. So now these two are again intersecting here. And if we have a parcel of air here and it is moved upwards, so it is moved upwards and it is reaching this point. So here what happens? What is the surrounding temperature?
Surrounding temperature is lesser in the upper region.
No, you just compare for the same height, what is the environmental lapse rate? So environmental lapse rate is here and this air parcel is here. So imagine if this is the temperature of the parcel and this is the temperature of the environment. So for the same height, the parcel's temperature is less than the environmental temperature. So what will happen here? It will move down, right? Because it cannot expand, it will contract. Surrounding temperature is higher than the air parcel's temperature. So it will contract and it will come down to its original position. And similarly, if the wind moves it to this direction, I mean downwards, and if the air parcel comes here, then here the temperature of the air parcel is higher than the surrounding air temperature for this height. Imagine we have this height. So this is the environmental temperature and this is your air parcel's temperature. So this air parcel temperature is higher than the environmental temperature. So what will happen? It will expand.
It will go
And
up.
by expansion it will move up. So it will come back to the same position. So no matter what the direction of the wind is, if the wind tends to move the air parcel upwards also, it won't stay upwards, it will come down.
And if the
And if the wind moves it down also, it won't stay down, it will again come to the top.
So
So
by this,
by this, the air parcel is
moving
not
anywhere.
moving
It is
anywhere,
going
it
to
is
be
going
in
to
the
be in
same
the same
position.
position.
So this
So
is a
this is a dangerous condition actually. It means that there is no movement of the pollutant happening. So the pollutant is stagnant over a period in the same place. Is this clear?
Yes, ma'am. Ma'am, can you please share some materials regarding this different based on
Sorry?
this?
Sorry?
Can you please share any material related to this concept differently?
Material.
Yes, ma'am.
What material?
Ma'am, related to this concept.
You can refer to the books which are prescribed in the course.
And ma'am, what about the questions, ma'am? Why we are not doing any practice questions in this
We did last week, right?
session?
Yeah, we can move to the questions if you want. I had a few more concepts to explain, but if you want, we can move over to the questions. Is everyone okay with that?
Yes, yes, yes.
Okay, so the first question. So, can you tell me what is sewage? Sewage is a
Sewage.
type of wastewater which is generated from domestic, industrial, or agricultural sources, or all of them.
I think option is A, domestic sources.
Sewage basically mixture of all this wastewater.
No, actually, we only refer to sewage as that which is coming from domestic sources, from homes, etc. So, whatever comes from industry and agricultural is called effluent.
Yes, ma'am.
Yeah. So
That's why
that.
A.
Yeah. So the treatment process for that is different from what happens to domestic wastewater.
Yes, that is
Sewage
coming
is.
STP, and that
Yeah. Yeah.
that effluent come in ETP or CTP, I think.
Yes. Yes. So, next question. Agricultural runoff is a type of point source or non-point source.
Ma'am, non-point source.
Yeah.
Ma'am, you were telling that somewhat portion is remaining of your concept. What was that?
We'll solve the questions. You wanted to solve the questions, right? Okay, so the next one. Which of the following is a source of grey water? So first, can someone tell me what is grey water?
And grey water is the uh, discharge water from sinks in the domestic sinks. It is a mixture of toilet sinks. Means the water coming from this.
No, basically,
Uh,
grey water is wash, kitchen waste water.
Yeah, kitchen. Only kitchen or anything else?
from bathroom.
Bathroom.
Yeah, bathroom and kitchen.
Yes.
So here the options given are toilets, industries, urban runoff, and bathroom. So here the last option is correct. So the next question.
I think there can be two options, ma'am. Toilet can come, ma'am.
Toilet water is
Okay,
black
so
water.
can you tell me what is black water?
Hmm.
Toilet water comes under black water. Both are separately collected. So the next question, which of the following pollutants causes the question is, which of the following pollutants causes methemoglobinemia? So it's a kind of disease which makes the babies' faces turn blue. So it's only it only affects babies, not adults. So options are chromium, arsenic, nitrate, and fluoride. So can you tell me the correct answer?
It is caused by nitrates, which you called as a blue baby syndrome.
Yes.
Arsenic and fluoride both.
No, the correct answer is
No, no, no,
nitrate.
no, no, no. I'm saying arsenic and fluoride can affect the like everyone.
Yeah. Okay, next we will solve one numerical. So we are considering a river which is flowing like this. Okay. So in this river there is one pollutant stream which is entering. Okay. So this stream is having a definite flow rate, and already the river is also flowing. So the stream is also continuous. So the flow rate of the waste stream is 0.75. Into 10 power 6 meter cube per day, and the flow rate of the river is 15 into 10 power 6 meter cube per day. And
even though the river is
pure,
sometimes
because of previous pollution,
it will already have
it will already have some pollutant concentration. So the pollutant concentration we call this background concentration. So the pollutant concentration existing in the river is 0.5 milligrams per liter, and the pollutant concentration in the waste stream is 500 milligrams per liter. Now, assuming that as soon as the effluent is entering into the river, it is getting completely mixed. Okay, it is getting completely mixed. So I want the concentration of the pollutant at this point of mixture. Let's call it A. So I want the concentration here, just as it enters the stream and it gets completely mixed. How will you find this?
Ma'am, I'm not sure about the formula.
Okay, so the formula is concentration of the mixture, like at the site of the mixing, equals to the concentration in the waste stream multiplied by the flow rate of the waste stream plus the concentration in the river multiplied by the flow rate of the river divided by the flow rate of the waste stream plus flow rate of the river. So why we are doing this? If we multiply the concentration into the flow rate, for example, you take the waste stream. The waste stream is having a flow rate of 0.75 into 10 power 6 meter cubes per day. So converting this into liters, can you tell me how many liters per day it will be? So it is
0.75 to 10 raised to power 3.
sure. 1 meter cube is 1000 liters. So it's going to be 10 power 9 liters per day. And when we multiply the concentration of the pollutant in the waste stream with the flow rate in the waste stream, what we are doing is we are multiplying the concentration in the waste stream, which is 500 milligrams per liter, multiplied by 0.75 into 10 power 9 liters per day. So here the units are milligrams per liter multiplied by liters per day. So volume will cancel out. So what you are getting is how much mass is present at this point. How much mass of pollutant in milligrams is present, that you can get. Okay. So similarly, if you find out the concentration of the pollutant in the river water multiplied by the flow rate of the river water, that will also tell you how much mass of pollutant is already there in the river. So you have this. Okay, you first tell me, calculate and tell me what are these values. Multiply and tell me what is this.
From 375 milligram per day.
375 milligrams per day. Okay. And what is the pollutant concentration in the river, pollutant mass of the river?
I mean, the above just add 10 raised to power 9 multiply.
How much is this?
I mean, in the above part, just add 10 raised to power 9. 7.5 into 10 raised to power 9.
So now you know how much mass of the pollutant is there. So if you divide this by flow rate, we'll add both now. 375 into 10 power 9 plus 7.5 into 10 power 9 according to this formula. To find out what is the concentration immediately at the point of mixing, you can use this formula. So according to this, so denominator is going to be 15 10 power 9. So can you tell me what is this? What is the answer?
But 26.25.
Sorry? Can you repeat?
26.25.
Okay. Units?
Milligram per day.
Okay, this is in milligrams per day. And this is in liters per day. So tell me.
Sorry, milligrams per liter.
So when you have a stream entering with the concentration of 500 milligrams per liter, and already the river is having some background concentration of 0.5 milligrams per liter, at the point of mixing, you will have 26 milligrams per liter, which is less than what is the incoming effluent is having, but higher than what the background concentration the river was having. Is this clear?
Yes, ma'am.
Okay, so do you have any more questions?
And what was your concept remaining? You were telling before.
I was just going to discuss about the Gaussian Bloom model. I mean, the Gaussian dispersion model.
Can you explain that?
Now it is. I mean, we don't have time. Already, it has been more than 2 hours. So. And all these concepts have been explained in the video lectures also. You can just go through them.
Okay, thank you so much, ma'am.
Okay.
Can I leave now?
Yeah, you may.
Thank you.
Thank you.
Thank you, ma'am.